Okay, my name is Sebastian Mejia. This is my final presentation here for Engineering Tech 196. And here we go. So I made a underwater unmanned vehicle. That's what I'm calling it, the UUV. So it's basically a drone, but for underwater. And I know these have been made in the past, but this is kind of like my design here. This design is to be used with a remote controller, and the wings will be able to move in order to facilitate the pitch of the vehicle. So basically what that's going to do is it's going to allow for the drone to move up and down without using motors on the wings. So the wings will essentially control the flow of the water around them. Now, it's also powered by a single rudder in the back, which I'll show you here in a second. So, it's my initial design. The initial design called for over here two additional motors, but upon further inspection of the CAD model with the shorter wings, I don't really like how it looks, so I kind of changed things up a bit. I also changed up the rudder as well. But this is what the initial sketch looked like there. Now, this is what the CAD model looks like. It looks a little different than what I initially designed it as you can see, the rudder is just one piece in the back here, and it's more of like a cylindrical shape than I initially thought, and I thought this would probably be the best, most aerodynamic way in the water. So I guess aerodynamics in the water, I thought this might work well, and if I ever R&D this thing, then we could test that and see if my theory is correct or not. But the wings are here, and these wings, I'll show you how this works in the kinematics, how they are supposed to essentially flap up and down. Some of the workbenches I used are assembly design, generative shape design, static study, kinematics, and part design as well. So some of the lessons learned, it's helped me understand kinematic stress analysis on like a more functional level, like making an actual production part. It also helped me find some skills in surfacing and assembly design, and some of the difficulties I had were actually trying to get all the geometry to match up and make everything essentially agree with each other. So with that being said, I will show the CAD model now. And this is what it looks like here. So this is kind of like how it looks like in 3D. Let's kind of get a good look at everything. Bottom there, I added ABS material to this for the stress analysis on the wing. Now, ideally, I don't want ABS. I would want to make these wings at least out of carbon fiber, and maybe the whole thing out of carbon fiber for strength and weight. So I'm going to hide this and show the kinematics now. So I'm going to go back to here and then play it. So see how that kind of flaps up and down. So that's what the wings are supposed to do. So imagine when this is flowing through the water with this thing going at full speed, the wings, when they go up or down or whatever angle they need to be, will essentially control the angle of the vehicle itself. So stop that there. And I did a little bit of a stress analysis here on the wing with some downward pressure at 250 Newton meters of force. So this is what the results came back as. So I'll go ahead and play the simulation here. So, oh, I forgot this isn't hide. I hid the test wing. So let me take it out of hide. There we go. All right. So now we can go ahead and run the simulation. Okay, great. So, so the results here are like so. So of course with ABS it's going to start bending at 250 Newton meters, but it's kind of interesting to see what the main points of stress are. So over here it looks like it's going to have a bit more stress than kind of like geared towards where the body is. So looking at some of these other modules as well, we can see like the deformation, how that looks like. So pretty interesting there, 250 pounds. I expected a lot more, especially with ABS material, so that's not bad at all. So that's kind of what all this looks like. And then attention. So that is my project. Thanks for watching.